Should be easy to understand this one. So dot product or scalar product. So the dot product of two vectors u and v is u dot product v is equal to the magnitude of u times the magnitude of v times cos of the angle, where theta is the angle between u and v. Theta being between 180 and 0. So since the quantity on the right is a product of three scalar quantities, the dot product of two vectors is a scalar. So this is also noted as the scalar product. So some observations about the dot product is that the result of the dot product is always a scalar quantity. The dot product can be negative, zero, positive, depending on the size of the angle between the two vectors. The dot product is only calculated for vectors when theta is between 0 and 180. When two non-zero vectors are perpendicular, their dot product is 0. So we're just going to be using the definition from above. Let's calculate the dot product of each of the following vectors. So I got the magnitude of u is 8, the magnitude of v is 15, and theta is going to be 50. So u dot product v is going to be 8 times 15 times cos of 50, which gives me a value of about 77.13. So I have a positive dot product, which means that my angle is going to be acute angle. So I have my magnitude of u is 14, magnitude of v is 23, my theta is 90, which means that my dot product should give me 0. 14 times 23 times cos of 90, which gives me 0, which means u and v are perpendicular. And the last one we have, magnitude of u is 3, magnitude of v is 5, so I get 3 times 5 times cos 120. This is going to be roughly negative 7.5. So I have my negative dot product, which means that my angle is an obtuse angle. So as you can see, dot product is not too difficult to understand. However, there are going to be rules that revolve around it. So example 2, I want to prove that two non-zero vectors, u and v, are perpendicular if and only if u dot product v is equal to 0. So I need to prove that u is perpendicular to v if and only if my dot product is equal to 0. So I have case 1, which is to suppose, given u is perpendicular to v, I need to prove u dot product v is equal to 0. So for example, I'm going to get my dot product u dot product v is equal to the magnitude of u times the magnitude of v, and because it's already given that they're perpendicular, my cos or my cosine, my angle is going to be 90 since we're assuming they're perpendicular already. And as I know, cos 90 gives me 0, so automatically this proves that the dot product of u and v gives me 0. Now I have case number 2. So we prove case 1 to be correct. It gave me a dot product of 0. So suppose that we already know my dot product is equal to 0. I need to prove that U is perpendicular to V. So basically what I'm proving now is I know my dot product is 0, so I need to figure out what angle that happened at, okay? So I get 0 is equal to cos theta. And from basic trigonometry, guys, sorry, at what angle of theta does cos give me a value of 0? So what angle of theta does cos give me 0? 90. Which means that it is proven. Therefore, U is only perpendicular to V if and only if their dot product gives me 0. Okay? So that's the only way this is going to work. Now, there are products or properties of the dot product. So again, they're very similar to basic algebra. So I got the commutative property. So I got dot product of U and V is the same thing as saying the dot product of V and U. So A times dot product of U and V is equal to A vector U dot product V, or U times the dot product of A V. Now we have the distributive property, which states that U times the dot product of V plus W is the same thing as saying U dot product V plus U dot product W. And the last one is U dot product U gives me the magnitude of U squared. Okay. So let's do some examples. So I need to expand and simplify J dot product 3J minus K. So this is going to be J dot product of 3J minus J dot product of K. So I get 3 dot product J dot product J minus, and I can use my, because J and K are two vectors, I can take the magnitude of J times the magnitude of K and multiply it by cos of 90 degrees. So this is equal 3 times the magnitude of J squared minus 0. So I get 3 times the magnitude of J squared. So let's give J a value of 1. So let's just say J is a unit vector, which means the value of J is 1. So I get 3 times the magnitude of 1 squared, which gives me 3 times 1, and that would give me 3. So now the next one we have is 2 vector u minus 5 vector v, dot product of 4 vector u plus 4 vector v. So this is going to be similar to algebra or distributing or distributive property or FOIL. So remember, remember we have I, J, and K, and they're all perpendicular to each other, which is why J and K make an angle of cos 90, right? Because I, J, K are all perpendicular to each other. And because J is a unit vector, the value of a unit vector is always going to be 1. So that's why I assign J a value of 1, because J is a unit vector. So now for the next one, I'm just going to literally use FOIL. This is back to the basics, grade 9 algebra. So this is equal to 2 vector u dot product 4 vector u plus 2u dot product v minus 5 vector v dot product 4u minus 5 vector v dot product vector v. So again, multiply just my coefficient. So I got 8 vector u dot product vector u plus 2u dot product v minus 20 v dot product u minus 5 v dot product v. So we can take my middle term as sort of a like term, okay? Because u dot product v is the same thing as v dot product u. So I get 8 times the magnitude of u squared because of our last property of the dot product minus 18 times u dot product v minus 5 times the magnitude of v squared. So that is how we would simplify this guy right here. So now the dot product in component form. So if vector u is u1 and u2, if vector v is v1 and v2, then u dot product v is u1 times v1 plus u2 times v2. If u is u1, u2, u3, and v is v1, v2, and v3, then u dot product v is u1 times v1 plus u2 times v2 plus u3 times v3, which means we can now find the angle between the two vectors in component form using the angle formula. So if we only have it in component form and we don't have the angles, Priyanshu, I think my V's and U's look the same, which is why it's right here, UV, right there. Yeah, so my apologies if my U's and V's look the same. I don't try to do it on purpose. So now if we don't have the angle between the two vectors, but we have all of their components, then I can find the angle by rearranging what I had before. So cos theta is equal to u dot product v divided by the magnitude of u times the magnitude of vector v. So now let's get into some examples. So I want to find the dot product for each of the following pairs of vectors and state if the vectors form an obtuse or an acute angle. So remember, guys, from the first example of the first page, an acute angle, do I get a positive or negative dot product? Let's see if you guys remember. Yeah. So when I get a positive dot product, I get an acute angle. A negative dot product gives me an obtuse angle. So let's figure out U dot product V is equal to just 3 times 2 plus negative 5 times negative 1, which gives me 6 plus 5, which gives me 11. So I get my dot product is positive, which means my angle is acute. So I got an acute angle. Now my next one is three-dimensional space. So I got A dot product B is going to give me negative 6 times 4 plus 3 times 5 plus 0 times negative 8. Who can tell me the dot product of A and B? So tell me the dot product and what angle we get. Okay, I get negative 9, which means therefore obtuse angle. Okay. And now example 5, I want you guys to find the angle between the following pairs of vectors. So I got the first one is C, vector C is 1, 2, 3, and vector D is negative 1, 3, and 5. So again, I get cos theta is equal to C dot product D divided by the magnitude of C times the magnitude of D. So again, let's figure out the dot product first. It's going to equal 1 times negative 1 plus 2 times 3 plus 3 times 5. So who can tell me what the dot product of C and D gives me? Okay, so it's 20. So I got my dot product is 20. So I get 20 over the magnitude of C, which would be square root of 14, times the magnitude of D, which is the square root of 35, which gives me theta is the cos inverse of 20 over root 14 times root 35, and I get an angle of approximately 25.38 degrees. Now the next one I want you guys to do on your own, and I want you to tell me what angle is going to be between the two pairs of vectors for 2b, or for 5b, sorry. So do 5b on your own and then type your answer in the chat, please. Okay, thank you, Priyanshu. So my dot product between A and B is going to give me 0. So I get cos of theta is equal to 0, which means that my angle is going to be 90. So A dot product B is equal to 0, which means my theta is automatically going to be 90 degrees because of my dot product giving me 0. We're going to do example 6 last, and then example 7 and 8 I'll just do when you guys are on break, and I'll just post that note with it. I'll explain the steps. So after this, after example 6, I'm just going to do example 6, 7, and 8 while you guys are on break and doing work. And that should be it for today. So example 6 is if U is 3, -4, and 7, and vector B is -3 over 2, 2, and C. For what value of C are the vectors U and V collinear, which is a fancy way for parallel, and orthogonal means perpendicular. So based off what we learned today, how am I going to figure out how vector U is collinear to vector V? What property am I going to use? Yep, U is equal to KB. Vector U is equal to some scalar K times vector V. In this case, I got 3, -4, and 7 is equal to K times -3 over 2, 2, and C. So I get 3, -4, and 7 is equal to -3 over 2K times 2K times KC. So we don't know what C is. So in order for me to know that it's collinear, when I solve for K for the first two, they have to be the same number, which means I can assume that it's going to work to find C. So I got 3 is equal to negative 3 over 2k. When I isolate for k, I get k is equal to negative 2. So now I need 3, or negative 4, sorry. Whoops, almost messed up again. So I need negative 4 is equal to 2k, and I get k is equal to negative 2. So I get these two are the same. Therefore, I can assume that k is going to be negative 2, which means I can find my c value. So I get 7 is equal to k times c. 7 is equal to negative 2 times c, which means my c has to be negative 7 over 2. Now for my orthogonal or perpendicular property, what property do I need to do to figure out if two vectors are perpendicular to each other? Which dot product property? So if they're perpendicular, what does my dot product give me? Zero. So I get u dot product v is equal to 0. So I'm taking 3, negative 4, 7, dot product, negative 3 over 2, 2 and c is equal to 0. So you have 3 times negative 3 over 2 plus negative 4 times 2 plus 7 times c is equal to 0. So I got negative 9 over 2 minus 8 plus 7c is equal to 0. Now algebra, 7c is equal to 9 over 2 plus 8, and c is equal to 25 over 14.